Well, thank you for joining us at Looking at Living Systems. We're going to take a peek at your last organizing idea for this year for grades 4, 5, and 6, and we're going to see how we can tie in some scientific methods. As usual, we'll go through some progressions, what it looks like between the grades, because it truly is a spiral curriculum, some misconceptions, the verbs in the cusps, and resources available. And as always, we will have a Q&A time. So if you go to your living systems bin in your ECSD science supplies, you're going to find the green one with this lovely image, and in it you'll have that placemat. It's always really cool to see how it flows between the grades. So grade 1, we focus on the needs of plants and animals. Gone are the days of living and non-living, because we know better with those indigenous ways of knowing now that things like water and rocks, they have a history. They have a deep connection and importance to what we do in our lives. And so we don't go with living and non-living anymore. We go with the needs. Grade 2 is life cycles. Grade 3, we're talking food chains. Grade 4, we're looking at those external structures like mouths and claws and how animals respond to sensory stimuli. Grade 5 is super cool because we're looking inside at those body systems with the organs and the xylem and transport system of plants. And then in grade 6, we have a lot of scientific methods where we're investigating the biotic, abiotic, and diving deep into photosynthesis. But you'll notice throughout our entire curriculum, there's huge pieces of, taking care of our earth, like Earth Day was today. I hope you had a chance to maybe get some fresh air and clean up. And you're also going to notice in all of our grades and all of our organizing ideas that that word local keeps repeating. The only time it's not repeated a lot is in grade 4, because when we're analyzing those different structures, like the spines on a cactus, and we're thinking about desert, we do need to talk a little outside of local. But for the rest of the time, it's super local. See if I can, there we go. So grade 4, these are some of your misunderstandings that you might encounter with your students. Whenever we say animals and plants sense things, we don't want to anthropomorphize plants and animals and make them think that like they're alive and they have a personality. No, it's the big idea that all senses are related to survival, and there's that relationship there. And that those senses, they're never just decorative or for fun. There's always like an evolutionary purpose with all of these senses. Sometimes the change in the environment is not overtly obvious. And sometimes that those senses and how they respond take some time. Um, it's um, there's a big misconception that plants don't respond to changes in the environment because they don't have those overt senses like ears or brains, but they do. And a lot of times students think that big elephant ears, they only provide one function, but that's not true. Many of those external pieces of the animals can have multiple purposes. So we're going to go through the bands of cusps in grade, I'm just gonna, we have people who can't see the slides. Just a sec, I'll stop sharing. Here I'm talking along. Let's see if we can get it to go. Can you see it now? Yeah, it's working. Okay, maybe I won't record this. Oh, don't worry about the recording before. I'll record it a different time. Hey, do you want me to go back and check and go through some of those things? I can go back. Here's what I was. Oh no, it took me out. There we go. We went through the progression. So this is what your placemat looks like from your science bin. Then I talked a little bit about some of the misconceptions that some of our grade 4 students might come with. Then now I'm going to start going through some of those pieces. So we know our knowledge helps us not overteach or underteach. We have some of those language markers in the first band of grade 4, we see include and include. We have to talk about appearance, habitat, and structures. We need to talk about eating, moving, protecting, sensing, and reproducing. I've highlighted where we want to live is in the skills and procedures. That's the doing of science. So you're going to see some verbs, and that's what you're going to assess is find and classify local plants and animals. Demonstrate respect when interacting with plants and animals. Relate. Once again, that idea of relationships and kind of cause and effect and how they're connected is hugely important in our our science concepts here. So you're relating the external structures of plants to their functions. Everything has a purpose. You're also going to relate the external structures of animals to excluding reproduction. Do you see that in there? We don't need to go deep into that part. Even looking at the knowledge, we want to have the tendency to want to talk about like the stamen and the pistil of the plants and animals and flowering things. We don't need to go that deep. Now, I put Neil deGrasse Tyson there. It says, is it always a research project? We have a tendency with living systems when we're like, oh, plants and animals, let's do a research project. That's awesome if that's your English language arts and literature outcome, but nowhere in our skills and procedures does it say that we need to research. So just keep that in mind. Linked at the top too is simple activities where we can have students bring in stuffed animals or pieces from the environment, and with just hula hoops or digital, they can sort and classify by appearance, by habitat, and by structures. Next, we have the second band of cusps. Oh, here are some amazing curriculum crates to go with them for grade 4. We have Botanical Explorers, a journey into classifying plants and decoding external structures, where they're going to be physically building those pieces of the plants. You also have that wonderful model in your ECSD science bins. 2, you're going to see using Eric Carle's mixed up chameleon, those external structures. And that's a really cool one that was made by Copilot recently at a school. And so you'll see in that mixed up mammal sensory organs, a lot of choice boards in there to meet the needs of all of our students. 2, in the pacing guides, you're going to see some things like insect mouth part slide deck. And it comes with a really exciting kind of hands-on observation experience. You're gonna have clothespins, turkey basters, straws, and sponges, which represent different mouth parts of insects. And what are those mouth parts for? Are they for lapping, chewing, piercing, or siphoning? And so you get to bring in a variety of different foods or pieces and explore that way. 2, there's another band where we're looking that the sensory organs include ears, eyes, nose, tongue, and skin, and that they detect food, other animals, dangers, or temperature. Here is an ideal time in grade 4 to incorporate your scientific methods, especially when it says conduct an investigation. We know that is scientific methods. We have to relate those sensory organs to their survival and how they respond. Now, a lot of times we're like, well, what experiment can we do? Here's a couple of them for you. This phototropism and gravitropism is from one of our favorite websites called Let's Talk Science. Phototropism is that the plant will sense light and always grow towards the light. Whereas gravitropism is the plants always want to grow upright. That's so the xylem and the phloem, which grade 5s will learn about, they can easily transport that water or those nutrients when it's upright. So those are some simple experiments that you could do with your scientific methods inquiry cycle. 2, just putting out some simple foods on the tarmac at school. You're going to see that the ants want to go towards certain foods. Why is that? 2, we can always take things like pill bugs, or they're called roly-polies. And if we put them in a tray and cover half the tray, those roly-polies immediately are going to want to go onto the dark side of that tray for danger to protect themselves. Now, as always, you've probably seen these before, but last year, our wonderful assessment and science COP team made these beautiful learning progressions or kind of sample unit assessment plans for each grade and for each organizing idea. Here's a link to the grade 4 with your success criteria, your evidence of learning, and some learning experiences. There you will find some single point rubrics. 2, don't forget that additional resources we have are gizmos. You'll see here, some of them are intended to be for span quite a few grades, but we have some flower pollination digital simulation. We have the comparing climates. The honeybee hive talks all about the changes that happen in the behavior of the bees as they sense different things in their environment. So check out those digital simulations and always reach out to Kat or I if you need support in getting on Explore Learning, or you can access them through New Learn Alberta and use them whole group or assign them through Google Classroom. Now, we know we do have Edwin to support our new science as well, but I want to make a note that on Edwin, sometimes they retrofitted a little bit of their science stuff to keep up with our pacing guides. You're going to see that word adaptation, adaptation, adaptation a lot in grade 4 on Edwin. And what we want to say in our Alberta curriculum is respond to stimuli. It's not necessarily an adaptation. Same too, there's a lot of temptation to want to go and build all these habitats. And you know what? That's super cool. It fits really well with your computer science and the design process. So if you're wanting to build those habitats or build those animals, go for it with the lens of computer science. Speaking of computer science, we have a couple of activities or ways that you could integrate it. We can always go on to Scratch Junior or Scratch, Scratch, and have plant growth simulator in Scratch. We can have a plant move towards the sun or move towards a water source or food source. We can build an animal sense game. If a sound is detected, then the animal turns or moves, and that can be done, encoded, and designed in Scratch as well. Or 2, we can use our microbit timers, and you know those touch me not plants, or even a Venus flytrap. Graph, record, and use the microbit stopwatch to see how long it takes for that plant to react to the stimulus. 2, Minecraft is all the rage right now with that movie. We do have Minecraft education, and you can reach out to any of the consultants on how to effectively use that in your classroom. But it would be great to look at the different organisms in the different biomes and what kind of structures and functions do they have. For example, this animal has claws to dig tunnels in this biome. So you can always have some fun and engage your students with Minecraft education and living systems as well. Feeling good? Any questions about grade 4 before we move on to grade 5? Grade 5, here are some misconceptions that you might encounter. We're looking at body systems. There's going to be a lot of misconceptions that like the stomach is just for breaking down food, or blood is only for carrying oxygen. Or muscles are one system and bones are another system and they work the same way. You're going to have a couple of those, and that like xylem and phloem are the same. They're moving nutrients in the same way. No, they have different purposes. And plants have the exact same system like animals do. They're similar, and that's why they're grouped together, but we do need to clarify those similarities and differences. Notice in the knowledge section, it's going to give us our definitions. We don't go into cellular respiration or chemical and mechanical and all those pieces. So I put a big caveat there. Don't go too deep. It's going to tell you exactly what those body systems include. So when we're talking about the respiratory system, we know that it exchanges oxygen and carbon dioxide. It includes trachea, lungs, and diaphragm. Just those 3. We're not going into alveoli and pieces like that. Even the circulatory system. The definition is it moves blood around the body and it's heart and blood vessels. We don't need to go into capillaries and arteries and the chambers of the heart. You're going to look in your ECSD science bin for that magic school bus. And for this everybody classroom body session or crate, you're going to want to get the syringes, and those are found in some of your energy crates. Notice they include, we have the 4 systems: digestive, respiratory, circulatory, and musculoskeletal. And when we're talking about them, that it's complex. It's for movement, it's for nutrition, it's for respiration, it's for growth, it's for reproduction. Reproduction, you're just saying that that's how we make more of us. That very basic concept of reproduction shows up in grade 2 when we're talking about life cycles and we're talking about offspring, but we really don't need to go too deep there. Our verbs and our skills and procedures are relate. Once again, that cause and effect, that relationship. If this, then this. And that connects to computer science too with conditional statements. Examine the function. Examine means we might need to do a little bit of research on there. Identify is just pointing them out or labeling. And then once again, investigate the relationships between the body systems, oxygen, and nutrients. So the whole first one is really engaging. There's many opportunities to build those body systems. You can decide to do them whole class or piece them out. In the crate, you're going to see some fun things like three truths and a lie, and they have to gather information about the body systems and share it with each other. How the body system relates to plants is that because we had that circulatory system, plants have one that's similar but different. It's the plant transport system. And this celery seed to scientific methods plant transport system is going to be a really engaging crate. And 2, you're going to do your stereotypical where you get the celery stalk and we need to visually see and experience that food coloring going up in it. That really exemplifies those plant transport systems. And then there's really fun facts and ways to represent that. So grade 5, super, super fun. Once again, you also have an assessment unit plan with the success criteria and learning intentions, and includes things like from ARPDC and APLC and sometimes exams. There are gizmos for the circulatory system, digestive system, and musculoskeletal system. So you're going to want to check out those gizmos. Then 2, once again, for computer science, there's a lot of opportunities to tie in those. So we could use Scratch code to make an animation of how food travels through your body or nutrients. That's going to use sequence and loops and conditionals, kind of storytelling of the body. You can look at this, it's like a mini operation game with the Makey where physical computing meets digital, and you can code and have the different parts of the bodies talk as you push it. And then we can also use the microbit to have a pulse monitor, check our heart rate. Even in Edwin, there's a coding the human body systems. That's a little bit complicated, but lots of opportunities there. How are we feeling about grade 5? Sounding good? Sounding fun? There's so many great ways to, kids love talking and learning about their bodies. There's lots of cool gross body books that we can leverage to make things really engaging. Grade 6, we have quite a few pieces going on there. Some of those pieces of abiotic and biotic are going to feel very natural as those were part of the old grade 6 science curriculum. And then we have the whole really hands-on piece with the photosynthesis. So here are some misconceptions or things to watch out for with your grade 6s. A lot of times grade 6s think only the biotic components are important. No, those abiotic ones are there for a reason. They all interact. What is the relationships there? A lot of times just outside of our classroom in the field is an ecosystem. Kids think that it needs to be this fancy desert or this big wetland. No, just around our school, we can learn a lot about these pieces. You'll notice the word climate change again shows up in grade 6 living systems. You can connect that back to your earth systems and remind students that it's not just man-made things that contribute to climate change. Kids are going to think plants get all their food from the soil. You're going to need to, that's why we're doing those hands-on experiments and testing starch and testing glucose and testing our oxygen. A lot of kids will think that all parts of a plant can photosynthesize. And there's some misconceptions around glucose and starch too that we're going to need to be aware of for grade 6. So you're going to notice in the knowledge section of our grade 6 cusps that there's a lot of choice. You'll see all components of an ecosystem influence each other directly or indirectly. There's choice, 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 choice there. There are many types of ecosystems. There's choice there. And there was choice with those they'll be familiar with those because in grade 4, when we're investigating lithosphere, in grade 5, when we're investigating climate, we will have visited and learned about those ecosystems already. We leverage things like Google Earth to take a look at those ecosystems. When we're talking about gases being released too, we have our choice of wetlands, ocean, forests, or grasslands. Once again, I'd stick to something kind of local. To launch your grade 6, I would encourage you to use this biotic, abiotic nature hunt. There's so many opportunities to take our kids outside with Earth, with living systems. Once again, it says create a model or simulation to represent a change in an environment. You can do that through computer science or through Makey Makeys or Minecraft education. There's lots of cool things that we can do here. Please note, I have these red X's down here about the nutrient cycle and the carbon cycle. You're not going to see those components and those cycles anywhere in our living systems for grade 6. So as much as it might be tempting to over explain, they will get those pieces in junior high science. So make sure you look at within your knowledge to make sure you're not under teaching or over teaching, but it's a lot of comparing and creating. So grade 6 living system again is hands-on, and it gets even way more hands-on when we look at the skills and procedures for the second band of cusps. When we learn about photosynthesizing, you're going to see design and perform a controlled experiment, design and perform a controlled experiment, design and perform a controlled experiment. This is where you're living and assessing and doing so much scientific methods. Posted there for you with scientific methods. We officially use the word hypothesize in grade 6, and the definition is there. You'll notice in your ECSD science bins, you have that iodine ready to go. Iodine, a note, it's for teachers, not for students to be touching, but they can take pieces out from their lunch. And you walk around and you drop a drop of iodine to see that starch show up. If it is black, that is starch. So we have those pieces for you. Here we go. And the last band of cusps for grade 6, you're going to see we have a lot of choice again. Humans rely on plants in various ways. They're going to have a lot of experience with that because that theme is represented through all the grades. Even the certain plants considered sacred to First Nation and Métis, you can choose between sage, sweetgrass, cedar, and tobacco. I chose tobacco in this crate for you. You're going to examine ways that plants and animals rely on each other. A lot of that can be done through some of those Project Harvard Zero visible thinking routines, like purpose, complexities. I've listed that too. And then even it says discuss plants that are considered sacred. Some of my favorite protocols for discussion are fan and picks, which I've included there for you, or even chat stations are linked there as well. As always, we have gizmos to support grade 6. You're going to see Coral Reefs 1 talk about abiotic factors. Coral reefs too talk about biotic factors. There's the pond ecosystem, the prairie ecosystem, and then a general stem case ecosystems in which you can explore all those relationships. If one thing's change, what happens to the other? Now, what's really cool, and I'm hoping all your school sites have these, if fear not if you don't yet, but at the last round of school teams, if you attended a session with Cat or I, your site will have received 4 of the brand new version 2 climate action kits from Forward Education. These align beautifully with all the organizing ideas in your science. Here are a couple that I picked for living systems: optimizing plant growth, data-driven smart farming when we're measuring moisture and using a water pump, precision watering, and protecting pollinators with a bee counter. So if you did not receive these climate action kits yet, give Katarina Campbell or I a Teams message and email, and we'd love to come crash course you, your grade partners, even your whole staff on this wonderful all-in-one resource. It has all the physical computing pieces. It's run with a microbit. It has 31 ready to go lessons aligned to obviously it's new science, but also math and new social studies that's coming. But as we know, new social studies is kindergarten to grade 3 next year. So you can use it the year after. But let us know if you want to use that climate action kit. And that's kind of your really fast crash course on all things living systems for 4, 5, and 6. So I'm going to stop sharing now and see if anybody has any questions, comments, connections, want to go through some additional resources, need a few clarifications. Just throw them in the chat or unmute your mic, and I'd be happy to help you with any of those questions.
Have you gotten pill bugs before in Edmonton to use? Because you were talking about using pill bugs.
Yeah, I just go and if you lift up any rock in Edmonton, you're going to find like 20. I
Okay.
haven't purchased them, but if you are looking for insect exploration, I highly, highly recommend Butterfly Wings and Wishes. They have a lovely relationship with Edmonton Catholic and Center for Global Education. So that's Butterfly Wings and Wishes.
Is that like where you get the larvae and raise them?
Yeah, you can get a variety of like stick bugs and other things from them, or even vermi composting if you're into that. So they're a great local resource for supporting us with those pieces. And then of course, everybody wants the butterfly kits. They fit best right now with grade 1 when we're talking about needs of plants and animals, and then obviously grade 2 when we're doing life cycles. It's not as great of a fit for 4, 5, and 6. We have so many other cool things that we get to do.
Okay. Yeah, I used to play with pill bugs in Japan, but I didn't really think of us as having them.
Yeah, we have roly-polies everywhere. I call them
Yeah.
roly-polies, but pill bugs, yeah. You're welcome, Chantel. Thanks for coming. As you know, like email us at any time. We love coming out. We love planning. I'm actually doing this session, even though my background's Minecraft. I'm at St. Teresa School right now, and we did a whole bunch of unit planning and going through resources today and co-designing a couple of lessons. So I'm really excited for that. Good question, though, Monica. You're welcome, Irena. Anytime. Do you all have your climate action kits? Has anybody tried them yet? I know it's set up at Father Leo Green School. They have theirs both watering plants and checking their vermi composting. Sorry about the confusion at the beginning. I can't always see when I'm running it by myself. But that's kind of the quick lowdown on all things 4, 5, and 6 living systems. So thank you so much for joining and have a great rest of your Tuesday. And it's already Grace for Heart and Soul on Thursday. Okay, hope to see you around. And I'm going to do this one again and quietly record it one day myself. Okay, awesome, Monica. You're so welcome.